Hello everybody, and welcome to exercise 3 on page 20 of the workbook. And this problem, we're being asked to kind of graphically estimate derivatives. Okay, so let's read this question together. So consider the graph given to the right. Okay, so we're given the graph of a function. Use the graph to rank the following quantities in order from smallest to largest. Okay, and you might notice we're just given a graph of this function, no formula. So this is going to be strictly graphical estimation in this problem. We kind of have to think about what these numbers represent geometrically that we're talking about. And the key is to notice that the four numbers I just underlined are derivatives, which means that they're slopes, in particular slopes of tangent lines. And so we want to think of all five of these numbers as representing slopes, and we would like to compare those slopes. Okay, so why don't we start by actually drawing in the tangent lines that represent these slopes. Okay, so starting with f prime of 0, that means the slope of the tangent line to f at x equals 0. So I'm going to find the point x equals 0, and then just very roughly try to draw in the tangent line there. Okay, it looks about like that. Then we'd move on to the next one, f prime of 1. That's the slope of the tangent line at 1. Okay, so we'll draw in a tangent line there. Maybe looks about like that. Okay, and then moving on to 3 and 6, we'll draw tangent lines there. Okay, so the tangent line at 3. Okay, that one appears to have a negative slope. And then at 6, that's about here. So my best attempt at a tangent line would look like that. Okay, and the idea is, even though we can't calculate those slopes exactly, we don't have a way of doing that because we don't have a formula, we can compare the slopes graphically. Okay, so they want us to arrange these things in order from smallest to largest. That means that we want the smallest slopes to the left. Okay, so when you look at all of those tangent lines that we drew in, which one looks to you like it has the steepest negative slope? That's going to be the most negative number for the derivative. If I had to pick, I would probably pick this one, the one here at the right at 6. That appears to have the steepest negative slope, and so that should be the smallest of all of our numbers. Okay, and I'm just going to put some words here just to remind you of why we put that number there. It was the steepest negative slope. Okay, next question. Do you see any other tangent lines that have negative slope on our picture? Okay, I see one more, the one at 3. That still has a negative slope, but it's not as negative as the one at 6. And so as a negative number, that's a little bit bigger than f prime of 6 was. Still negative, okay, but not quite as negative. Okay, so we've taken care of, let's see, those two numbers on our list. And are there any other tangent line slopes that are negative, okay, from those 4 lines that we drew in? I don't see any other ones, okay, which means that the next number in our list should be 0. A 0 slope is going to be bigger than any negative slope. Okay, so we've taken care of that. And finally, over to the very right of our list of numbers should be the tangent lines with positive slope. Okay, so what's remaining to compare then are the lines at 0 and at 1. Okay, which of those two lines, if you had to pick, looks like it has the biggest slope out of the two? To me, it looks like we're a little bit steeper at 0 than we are at 1, which means that that number should be way over at the right. Okay, that's the steepest positive slope out of all of our numbers. Okay, and then at 1, we still have a positive slope, but it's not quite as positive, not quite as steep as it is at 0. Okay, so that takes care of the last two numbers, and it looks like this list describes the ranking of our slopes in order from steepest negative to steepest positive.